Hi everyone, I'm Isiki from FKEE UTHM. Today we'll be looking at some exercise related to magnetostatic.
Alright, now let's look at this exercise. So we have two infinite line. Okay, so this one is a line. So the length is infinite. So they are carrying identical current. Identical current, it means that the currents of I1, because here we have two infinite line. So assume that I label it as I1 and the second one I label it as I2. So both of them are carrying identical current. So meaning that I1 is the same as the I2 in the same directions. Okay, so the current flow in the same direction, and this line pass through the XY plane at these two positions. Okay, so identify, you have to find out, okay, at what locations. Okay, so the total magnetic field is equals to 0. Okay, so instead of finding the magnetic field, you have to find the positions, the location that will contribute, okay, to the total magnetic field to be equals to 0. So let's imagine these current lines in 2D. Okay, so first of all, I will draw 2D first. Okay, so imagine this one is your 2D diagram. Okay, 2D coordinate systems. Okay, so this is y and this is x. So the question said that this line passing through the xy plane. So this is the xy plane at these two positions. Okay, so negative 1 and 1 is here. Okay, negative 1 and 1. And 1, negative 1 is here. Okay, so if I view from the top, okay, so because it didn't specify what is the direction of the current, but it just mentioned that the current are at the same in the same direction, so I will assume that the current is coming out. Okay, so this one symbol is current. Okay, current coming out. Okay, coming out from the surface. So this is the direction of the currents. So when you have current flow, okay, so you could use your right hand rule to determine the direction of your magnetic field. So for example, in this case, okay, the first current elements. So according to the right hand rules, your magnetic field will appear in these directions. Okay, right, so this one is your magnetic field, right, using your right hand. And for the second current lines, okay, your magnetic field will be in these directions. Okay, so there will be at one position that the current from the I2, I will say that this is I2 and this is I1. So at one position that, okay, the I1, oh no, sorry, this one is I1. The magnetic field from the I1 will be in the opposite directions, okay, of the magnetic field, okay, from the I2. So I would say that it is something like this. Okay, opposite directions. So one is going this way and the other is going that way. So you have to identify the positions here. Okay, even though from the drawing we can estimate, okay, the position is around 0, 0, 0. Okay, you still can find out these positions by using mathematical equations. Okay, so first of all, let's look at what is the equations for magnetic field. Okay, especially for infinite line. So for infinite line, the equation is this one. Okay, 2 pi r and phi. So in this case, phi represents the direction of the magnetic field. Okay, for example, now you see this phi is turning like this. So this is the direction of the magnetic field in phi directions. So I is the same thing. So now if we have I1 and I2, and my intention is to find the hash total, which is equal to 0. So hash total will be equals to the summations of the magnetic field that is contributed by I1 and contribute by I2. When I add up these together, I'm supposed to get a magnetic field that is equals to 0. Okay, that is equals to 0. So meaning here, okay, so if I put it together, it will be H1 equals to negative hash 2. Okay, negative hash 2. So what is hash 1? Hash 1 is I1 over 2 pi r. Okay, and it is phi. It is phi. And I2 is, hash 2 is I2 over 2 pi r as well. And the direction is negative phi. Okay, they must be in different direction to cancel out each other. So meaning that, okay, if I1 is the same as I2, okay, to make them equals to or cancel out, okay, the distance between them must be the same. Okay, so this is the distance between them. Okay, so you have to figure out, okay, the distance. Okay, so the very direct way is to actually connect, okay, connect the line elements, okay, together. Okay, because this one is just purely the distance. Okay, so if you connect both of them together, okay, connect it. Okay, okay, the distance between them must be the same, means that it will be half of it. Half at the middle here, half of it. Okay, so the distance r here, okay, will be the same as the distance r here. Okay, so at these positions, okay, the magnetic field will be cancelled out. So obviously, the positions to make this happen is at the middle, at the origin. So the positions will be, I would say that the P positions will be 0, 0, 0, if you consider the Z coordinate. Alright, so this is the answer.